and that should be happening now. So welcome everyone. What we're going to show today is mainly a bit of awareness or showing ourselves because from the side of Flanders Make we're involved in the Rec & Com project, where we focus on the internationalization of companies that are involved in recycle-based composites or end-of-life processing technologies. And now I hope my slides advance, but I don't see it happening. Yes, that seems to be better. First, I'll give a short introduction why we're here and what the project contains or does not contain. Then I've invited a guest speaker from Vito, Evelien Diels. Thanks, Evelien, for joining us. You're a bit, not very well aware of what was happening before, but I think your story will fit in perfectly. Next, I'll discuss 3 missions that we're planning to non-EU countries, to the USA, to Japan, and to Singapore. There are 3 Belgian companies joining each of those missions. These 3 companies will present themselves, and then I will also very shortly introduce the other European companies that are joining these missions. A message that I want to give to the people attending here is, if you see synergies or if you want to join such a mission, do not hesitate to inform me or contact any of the companies involved. I think it's still possible to join, but on your own costs or expenses. And then, maybe the last 5 minutes we'll do a short discussion round or a question round. You can also type in any questions that you have already in the chat, and then we see it at the end. As I mentioned, this activity is part of a European project funded by the COSME program, where 5 clusters or research institutes are involved in the consortium, and I'll give a short overview of who is who and why they are in this project. The first one is the project coordinator. It's Next Technology Tecnotessile. They're based in Italy and Tuscany, and they are the reference point for research and technological innovation in textile and in textile machinery. And they're also the managing body of what they call the Tuscany Fashion Cluster. And as I mentioned, they are the project coordinator, so they are on top of the list. Then in France, we have Textera. They are a bit the French counterpart of Next Technology Tecnotessile. And Textera is an innovation cluster dedicated to the French textile industry. They have almost 200 member companies, and they have been involved in over 200 funded projects since 2005. Then we have PGM from Poland, which is a cluster that relates quite well to Flanders Make, I would say. It's a Polish automotive group, and they are a Polish association that gathers automotive suppliers from Poland. And their goal is to increase the competitiveness of these companies. Then the 4th cluster involved is Cluster Legno Arredo. They are involved, as you can see from the picture in the bottom right. They are a cluster for furniture and home systems, and they're located in the region of Friuli, Venice. And last but not least, we have Flanders Make, to which I belong. I'm Jan Stroobans. Sorry for not introducing me earlier. I'm a senior research engineer at Flanders Make, and we are a strategic research center for the manufacturing industry. We have more than 200 full-time employees and more than 500 researchers involved in research projects at the different Flemish universities. So that's the consortium. You see it's mainly textile, automotive, and furniture. To get to the next. The objective of the project, as I said a bit earlier and shorter, is indeed to support European SMEs in their internationalization in terms of producing recycle-based composites. And it could be on the input side, for instance, if they have material available, or if they create new materials that are based on recycled materials. It could be in the manufacturing stage. It could also be in the end of life stage, for instance, if they have scrap or waste material that can be reused in other or in other new materials or recycled materials. The project has set up a joint internationalization strategy, and 3 markets or 3 regions have been selected before starting the project based on a small market study of the different clusters. And those regions or countries are the US, Japan, and Singapore. We're currently doing in-depth market studies for these regions. And in the beginning of this year, we did an open call for SMEs to join on a mission to these 3 countries. And the companies that will present themselves later in this presentation or webinar, they have applied and they have been selected to join one of these missions. And the end goal is indeed to help them internationalize their business and to sign cooperation agreements and business agreements with other companies from other European regions, or preferably companies that are based in one of these 3 non-European countries. Not going to read everything that's on this slide, but yeah, I think it covers the goal is to cover the entire value chain, but we focus on 3 sectors: textile, automotive, and furniture, mainly because the clusters that are involved in this project are focusing on that as well. They seem a bit disconnected from each other, but I'm quite sure that materials or techniques can be reused across these sectors. And then, as I announced a bit earlier already, we have Vito as a guest speaker. Vito is a bit the counterpart of Flanders Make, I would say. They are also a strategic research center in Flanders, but their focus is on clean tech and sustainable development, if I'm right, Evelien. I think you can explain a lot better than me. And I invited Evelien to give a high-level overview of value chains and how they evolve with increasing sustainability. So the floor is yours, Evelien.
Thank you, Jan. Yes, hello everyone. So my name is Evelien Dils and I work at Vito. Vito is the Flemish Institute for Technological Research, and indeed we focus really a lot on sustainability, clean tech, and that is the real focus of our activities. We don't target one specific industrial activity, let's say, or sector. But we do have specific research groups linking to specific topics. I have not included slides on Vito, Jan, because we only have 10 minutes, so I will just very briefly explain. I myself, I work in the unit focused on sustainable materials management, where there is a technological part, but also an important policy-oriented part of research, both to policy makers, but also towards company policies, for example. And where, of course, classically the waste story, but now more circular economy is the key let's say, throughout our activities. And yeah, when we talk about circular economy, what do we mean specifically by that? Of course, everyone knows waste management from before and the waste hierarchy. And of course, that is still very important, going from reduce, reuse, recycle, and so on. And if you still have your waste that you need to dispose of, that you do it in a controlled and yeah, let's say managed landfill, for example, or release. However, if you talk about a circular economy, that has a different objective from the start, and the real aim is that you maintain the value of products, materials, resources, for as long as possible. You really want to make sure that if you produce a product, that you keep that product's lifetime as long as possible at a highest level of value. If the product as such is no longer useful, that you try to, by remanufacturing it or repairing it, extending its lifetime, and only when that is no longer possible, that you either try to use the components or specific materials, again, for as long as possible. And as such, really try also to minimize the generation of waste. Yeah, you can go to the next slide. Yeah. Oh, yeah. So the value of your products or materials is one thing, or one way to look at it. In Flanders, Vlaanderen Circulair has also translated this into functionality of materials, which you can see here in this graph. So what is really the difference between the classic linear economy and what we want to move towards a circular economy is that you try to keep your products at the highest possible functionality, your products, your materials throughout their lifetime. Meaning that in a linear economy, you produce your product, you use it, and then it's at its highest point in functionality. And after use, when it's end of life, it just has no further function, and that's it. In a circular economy, you really want to extend this, and you do this in each of those ups and downs, let's say, in the graph, through the different R strategies, like reusing it, repairing it, remanufacturing your product, or in the end, recycling your materials. An important difference, which has a very important impact also on value chains, is the fact that we need to move away from this waste management perspective, which is still something that is very much embedded in standard practice, let's say, along a lot of value chains, where you really look from your waste perspective. You push your waste into your value chain and you try to find a way to recycle it and to get rid of it as such and put that on the market again. Focus is really to get rid of your rubbish, to focus is efficiency, quantity, yield. You really want to make sure that you still produce something based on your waste. However, what we need to move towards is a more market pull, in the sense that what is it really that the market needs? What are the characteristics of materials inputs that the market needs? And how does that translate back into the value chain, into ways of managing your materials, resources into secondary materials, really looking back at not just I can produce a recycled material, but maybe with the wrong characteristics or the market is not waiting for it, but looking at we have a demand from the market. How can we use end-of-life products and materials and make sure that we produce the right secondary material, making sure that you focus on effectiveness instead of efficiency, and quality and purity for input flows towards the market. So it's really a shift in perspective that we need to obtain. That means also that we move away from what is in a linear economy called a waste manager. So really you have your value chain, and at end of life, you end up with your waste. What to do with this? You can, of course, recycle it and put it back into your material value chain, or get rid of it, discard your waste through incineration or landfill. When we go into a circular economy, it really becomes a material manager, a material stock manager throughout the different stages in your circular value chain, or as much as possible circular value chain. Of course, you will still require resources to be put into this value chain. You still will have material losses at end of life. What is the objective is that you try to optimally use your materials throughout your life in order to keep that functionality and value of your resources as high as possible. So really what is important here is that circular economy is more than the next waste management strategy. It goes beyond. Will go also impact, it will impact the core business of a company, because you will need to collaborate in a different way throughout your value chain in order to really obtain this material management perspective and the market pull. It creates, of course, opportunities in circular economy, especially for a region like Flanders, where we don't really have any or very little natural resources available, and where we are very much depending on global supply. But a key point is that circularity is, of course, not the objective. Sustainability is the objective. Circularity can be a means to reach sustainability, but it is not necessarily always the answer to everything. And you really need to put it into perspective and translate it into a feasible business model, but also looking into the other aspects of sustainability beyond the material and resource perspective. And when it comes to business, Vito, we have been working together with a lot of companies, of course, also policymakers. But when we work together with companies, what you really see is that it's not something as a company you yourself can say, I will be going for more circular practices, or whether it's about a different business model, like service models, for example, you want to implement, or using different input materials and so on. This value chain perspective becomes much more critical for your activities. As a company, why is the circularity in your business so important? Of course, you have the environmental objectives, but it can also really help in reducing costs, accessing new markets because of different practices, different types of materials that you use or produce, different types of clients that you want to reach. It can also help you in being more resilient when it comes to shocks, for example, in supply, resources, prices. We have been talking about circular economy and the importance for years now, like when it comes to prices and access to resources, but we always felt it's not happening. The logic is there, but it's not happening. Now, while in the last 3 years, with everything that has been happening and is currently happening, you do see the urgency is more there, and you do see that there's much more attention into really looking into working differently, implementing more circular businesses and so on, really to support you in that resilience. And a very important one, looking from this value chain perspective, is the fact that you will have to build stronger relations. When we talk about, for example, the use of recycled materials as an input flow, of course, you need to be able to get the right quality, the right purity of inputs into your process. So it's not a matter of, we need this amount of material, let's scan the market for the best price. It's often also really this continuity, this quality characteristics that need to be a determining element. So building relations with suppliers, with clients, maybe also with competitors, looking for pre-competitive collaboration in order to try out new materials, looking into new developments and so on, really becomes much more important. It can help you circular businesses in compliance with investors, but also finding new talents, clients, and so on, because it is gaining traction and gaining more importance. And it can help you to become more future-proof, looking at the different policy now, looking at Europe perspective, European perspective now. It can also help you in doing that. And what to take into account, of course, there's a lot I can say about this. I only have a couple of minutes left, so I will not go into details, but you need to think about your market access, of course, which is really important. Not only the technological knowledge, also financial means, getting the right loans. It's not always that easy when you talk about circular business. It's a different perspective also for investors and so on. This interaction with suppliers and clients and competition. Scalability. Of course, you need to make sure that you reach a certain minimal scale, but also too big is not necessarily always the right way to go, and what is in the right pace to do that. And replicability. Sometimes like Jan also said, maybe you do something in one sector with a specific activity, but it could as well be within your organization that you can replicate it, but also transfer it to other markets. And of course, then you have the market structure and so on that really needs to be taken into account. And then also the resilience, of course, it can help you in being more resilient, but you need to take some factors into account. At Vito, at this point, when I heard about the focus sectors, textiles is really some sector where we are working in a lot. And we have now recently set up this Horizon 2020 research project called SCIRT, which stands for System Circularity and Innovative Recycling of Textiles. Everyone or a lot of people know about the recent strategy from the European Commission on sustainable textiles. There's also new legislation coming up for selective collection of textiles in Europe. So there will be a huge amount of resources that could potentially be used as a secondary material. But of course, technology still needs further development and so on. And also a lot of brands are focusing on using more recycled input materials for their production of fashion items. But today there is still a huge gap between the demand of those brands and what the market delivers as recycled fibers today. And this is really this waste push perspective versus the market pull perspective. And what we wanted to do with this project is really start from this market pull, from the material characteristics that the brands are looking for, and see to what extent the technologies need to further develop to produce the right recycled fibers, but also how that translates further along the value chain towards collection, towards sorting, dismantling, and so on. And of course, also towards the right system conditions to be able to make this a feasible model and really make sure that this new value chain collaboration could actually work, looking, for example, into transparency across the value chain, but also other policy-related activities. So this is just a very short introduction. Of course, feel free to reach out or ask questions later on.
Thank you, Evelien. Nice overview, and I think I will have to adapt already to some of the the suggestions that you made, but we'll see it happening later. Back to the companies that will present themselves in a moment. As I mentioned, in the Rec&Com project, we will do 3 missions to the USA at the end of this year in October. 1 in Japan in the first half of next year, and 1 to Singapore in the second half of next year. And 5 companies will join those missions. I mean, 5 Belgian or Flemish companies will join that mission, and yeah, 1 company of every other cluster will join as well. And the idea is there indeed to find these synergies in the value chain, to see who needs what, who can offer what, and to find a match in that respect. Yeah, this is a bit of detail. The USA mission will happen in October 2022, with aligned with the Composites and Advanced Materials Expo. There will be a more detailed agenda coming up later, but it's not fully finalized yet. And then the 2 other missions will be happening next year. So I've invited the Belgian companies that have been selected for these missions. The first one up is the USA mission, and there we have been able to select Aconcore, to join that mission to the US. So I think, Thomas, if you can take over the screen and you can share your slides.
Thank you, Jan, and good morning, everybody. Let me indeed share my screen and I will launch the presentation. Here we go. Good morning, Tomasz Szanecki from EconCore. We are located in Leuven. And I'm gonna try to roll through those slides rather quickly as the time is limited. So let me start with this slide that explains a little bit what a sandwich panel is. And sandwich panel is what EconCore is about pretty much. So just to start with this, here we have an example of a monolithic panel with certain thickness, certain stiffness, certain weight. Now, using exactly the same material type as in this monolithic construction, one can construct or one can build a sandwich panel with relatively thinner or thin skin layers with a low density core in between. And thanks to the sandwich effect, with just a small increase in thickness, one can target the same bending rigidity at much lower weight compared to this monolithic material. And this can be optimized very nicely, having thinner skins, thicker core. One can go to, in this example, 80% weight saving. So sandwich panels can save weight, but that's something that I think we all know or feel. But what you want to stress is that when you're saving weight, you have the potential to save costs as well, because saving weight means saving material. Saving material should mean saving costs as well. Very often for sandwich panels, this is actually misbalanced a little bit in that regard, that there are those non-automated batch-wise organized production methodologies used for sandwich panels, and those sometimes are overwhelmingly high, providing that sandwich panels are getting finally more expensive compared to these monolithic structures. But the point here is that if we have an automated production process, if we can run an automated production process for sandwich panels, then we can be very effective both on the weight and cost saving level. And there are different cores, sandwich cores that you can find on the market. There are foams, there are those cup-shaped structures, there are the fluted boards or corrugated. Honeycomb is just one of a few, where honeycomb for a reason has been recognized and is being used by the aerospace industry as a structure of choice. It does have the best mechanical performance to weight ratio. The issue in the past was the manufacturing cost, which indeed for conventional honeycombs was relatively high because of the batch-wise methodology of their production. But EconCore has taken a little bit different approach to that, and this aerospace honeycomb-like structure has been combined by EconCore with the production principles borrowed from the packaging industry, where automation and low cost is a must. So what we do is extrusion of thermoplastic materials in a thin film that are immediately rotationally converted by vacuum forming into these half hexagons that we fold up into a honeycomb structure. And at that moment in the process, we can end up with a honeycomb core structure, and we do that in many cases. But in fact, the beauty of the technology is that with this continuous production of the honeycomb core, we can laminate skin layers onto this honeycomb core on the fly with an inline integrated process, and that way we can end up with an added value product being a sandwich panel, not just a honeycomb core. So that's the technology of EconCore, which is patented. It's not a concept anymore. It's something that is being has been proven is being used in the industry. EconCore, with the facility in Belgium, is focusing on development and optimization of the technology as such. And from a business perspective, we've been licensing the technology. Then we also have a daughter site which we own fully in Germany, where we focus on production of polypropylene honeycomb core and polypropylene based panels with thermoplastic composite skins, polypropylene glass fiber composite skins. So the group consists of two companies, two entities. If you look at our licensees who have decided to take the technology of EconCore on board, there is quite a list of companies from different sectors and using different materials for the skin layers. Tata Steel would be using steel skins. The other ones would be using thermoplastic or thermoplastic composite skins, and they would be going to applications starting from reusable packaging, automotive interiors, a little bit of furniture, quite a bit of commercial transportation and building type of applications, and also there are some applications where, for instance, honeycomb acoustic performance is appreciated, and yeah, our products can find the use in those as well. Now, if you look at the direct offering of products that we make at our daughter site in Germany over here, that would be a honeycomb core that is offered to the customers who want to laminate skin layers, should it be thermoset or thermoplastic composite or anything else, onto this honeycomb core at their sites. But we also expanded the offering recently to semi-finished panels, so honeycomb core with laminated thermoplastic composite skins, either continuous glass fiber, shorter glass fiber, to offer this added value product, as the world is indeed calling for more thermoplastic solutions compared to thermoset ones, for instance. I will not dig in very deeply to that comparison, but that chart shows a little bit the potential of this thermoplastic honeycomb panels. Those blue bars over here represent the rigidity of them, and the diamonds show the weight positioning. So, for instance, if you compare such a honeycomb panel to a monolithic one, you can see that you can obtain relatively, or actually the same rigidity levels, and this at much lower weight and cost, by the way, compared to these monolithic structures. Or if you compare 10mm plywood to this honeycomb panel, again, same rigidity can be obtained at a little bit more than 50% of weight saving. So very effective way to take the weight out, but again, we very often stress that taking the cost out is very often an inherent consequence of using our honeycomb technology. Those thermoplastic panels, well, next to these applications which are non-automotive, they also go to automotive applications. This is an example of a compression molded element, which has been also over molded at the same time. This is all very effective process where a short cycle allows to produce such an added value part. This is an example of a commercial trunk floor using our technology, our polypropylene honeycomb core combined with polypropylene glass fiber skins, again, short cycle compression molded into a fully functional part, very cost effective, very environmentally friendly because of the recyclability. But yes, it is still polypropylene, and in fact, you know, towards the sustainability or added sustainability aspects. Here, a few words about our recent evolution. We have optimized the technology, well, looking at the trends or following the trends of the market. How we've been, well, we had this interest to look at recycled materials. We have chosen recycled PET as the material of focus, and using pretty much the same process as you have seen before, we can today convert waste of PET into this added value honeycomb structures. And well, important to emphasize maybe that it's not necessarily the bottle grade of PET that we can use within this process, but we can in fact use post-industrial and post-consumer waste, which is very often allocating here and there. So we can use this low cost, low value, and difficult otherwise waste to treat in our process and produce this honeycomb products, honeycomb panels with a very low carbon footprint, by the way. So yes, the technology is about bringing performing solutions with minimal weight, minimal cost, and certainly with minimal environmental impact. That's what the technology is about. And with regards to this question, why are we joining the mission? Well, we want to expand our presence in the US market. Well, not just with the PP honeycomb technology, where we are ready on the American market with that, but of course the freight costs are quite high, you know, as you probably know. So making or producing lightweight solutions here in Europe and shipping them over to the US is not most efficient these days. We want to set our foot on the American ground, expand the sales initially, and then finally start up production and operations in the US. And once we are there, this will be valid for the polypropylene, but also for the recycled PET honeycomb technology. And of course, yeah, being in the US over the next months, well, we are aiming at exploration of this local trends with regards to sustainability and this needs of sustainable material solutions in the US. We know that it's a global call, but we want to, let's say, get a little bit better feel and touch of what the American companies that we'll be working with are thinking about it and when the timelines or how the timelines of those companies look like with that regard. That's pretty much it. Thank you.
Thank you, Thomas. A very interesting production technique as far as I can tell, and also, yeah, the needs that you have fit perfectly with the goals of the project to help a company internationalize or get some foots on the ground or boots on the ground in non-European countries. I hope you can see my slide again. These are the companies that will be joining us to the United States in October. Polyloop from France, offering recycling equipment. DRP Group from Poland, offering recompounded plastic raw materials. And I've learned from Eveline's talk that I should also mention the needs that these companies have. I can imagine they will also need some input material or material that they can start from. Then in the bottom left, we have Manifattura Maiano. They're more in the textile branch. And then on the bottom right, we have Santa Lucia Mobili. They produce home and hotel furniture. And what's typical for these furniture companies, as you will see later, their main interest is in exploring new materials or finding new materials. So I think there might be some synergies there. Next, we have the mission to Japan, where Covas will join us. I think Covas' specialty is thermoplastic tanks. Normally, Tony would present, but Sabine is falling in for Tony, if I'm correct. Sabine, are you there?
I am, but I have to say I've never seen the slides before, and Tony told me you were going to do the presentation. So.
Okay, that's a surprise for both of us. Yeah, I think the first part is a general intro on who Covas is. I think you're way better to
I can
tell about that.
Covas is a Belgian company founded by Hans and guy.
Your sound is dropping away, Sabine. I can't hear you anymore at the moment, but it was okay when you started talking.
I did not change anything. Can you hear me?
Yeah, this is better.
Okay, good. So Covas was built up in 2000 with the idea to manufacture composite air pressure tanks. And it evolved during the years because other opportunities came along. And for the moment, we are producing cold water pressure tanks. The picture you see at 2003, it was the small one. Now we are even making the larger ones from 2009. So it's composite water tanks from 60 liter to 450 liter. Okay, go, yeah. As from 2010, we are making cold water expansion tanks. So it's actually the same tank, but we insert a bladder in the tank. Our largest competitors are the steel tanks. Our advantage is that it doesn't rust. It's very lightweight, it's impact resistance, and it's 100% recyclable. As from, no, just one, yeah, from 2014, we are also making hot water tanks, and there is a US manufacturer who is who bought a licensee and he's now making those tanks in America. Fire extinguisher applications is also a thing for which our tanks are used, and that's mainly by a German company who makes those applications. From 2018, we started also the development of the thermoplastic tanks for automotive, for H2 and CNG. And we are going to the certification. We hope to start the certification by September for automotive thermoplastic tanks for hydrogen applications.
Okay, this is a bit the structure.
Yeah, there's the structure. It's a lot of blah, 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 but it's not useful for you.
You are in the top left. That's the most important
that's
one.
me. Then there's Tony and a recently new CEO, because Tony was not able to do everything himself anymore. In total, we are with 10 to 12 people working here at Coves. So
okay,
our time is good full.
True SME.
Yeah. So what is special about the Coves tanks is that it's a type 5 tank structure. So we start, or the history started by type 1, type 2, type 3, and so on. Mainly known is that there is a liner from any material, and then there's a material winded on it. Our type 5 tank structures, that is made in one piece. So we first have an inner barrier layer, then an outer reinforced layer, and it's all melted together. Those are the different advantages or disadvantages of the various types. I just don't know what I have to tell about that. It's very.
I think we can study it later, I think. Yeah. See some
mainly
easier production in type 5, but maybe not even sure if minus is more positive or negative. But
the main advantage of our tank is that it's low weight, that it can take higher temperatures, and it's also depending on which material is used. So we can vary in the materials depending on the applications.
And type 4 is what competitors typically produce.
Yeah, type 4 is with the liner and then winded around it.
Okay, good. This is a bit.
This is what we do today. So as I said before, from 60 to 450 liter tanks. For cold water, just storage tanks, the expansion tanks with the bladder in, which is sold under the name of sesame tanks. Retention tanks, the fire extinguishers, and the hot water storage tanks. This is what we're working really hard on. So the high pressure gas tanks, CNG and H2, chemical tanks for all different kinds of use, the larger tanks above 2000 liters. Project Mod Energy, it's something rather new, and it's a battery solution for a combination of housings in which, when the solar pillars
yeah, okay.
The energy which is produced by the solar pillars during the day, it's saved as a type of battery, and through a turbine and everything, it's given away again to use during the night.
Yeah.
And Project Moonraker, I know the name, but I cannot tell you anything about it.
Okay. That's it, I think.
Okay, good.
As far as I understood or know from Coves' side, Sabine, the goal in joining the mission and the project is to find more partners that want to take a license for the production process, I think. Yeah.
In Asia, we are not yet that familiar, so that's why. Yeah.
Okay, very good. Joining you on the Japan mission will normally be these 4 companies. So from France, Extract Hive, they offer recycled carbon fibers. From Poland, Magnetics Lamination. They have quite a lot of scrap material, and they convert that into recyclate. From Italy, Microtex, again in the textile sector, and from that textile they also offer scrap material and they make carbon fibers out of it. And then in the bottom right, the furniture sector, Krasivich. As I said before, they currently produce chairs and they're looking for alternative materials. Last but not least, we will have in the second half of 2023 a mission to Singapore, and there MOS Composites will join from the Flemish or the Belgian side, and there Stefan will shortly introduce MOS and why they are joining.
Hi, I'm Stefan Varambong from MOS Composites. I saw on the list from the people that I think most people actually know us already. I knew the other companies also, so I make it actually quite short. We are a small company, and we actually manufacture composites products. We also develop composite materials together with VUB and KUL, and we participate in a research program like MARES, which is about actually using the residues of industrial processes, which was based on the SBO Grante. And I strongly would suggest that you would visit our website, which is actually has much more material on it. Huh? So we go to the next slide. So now if I knew it was like this, I would not have printed it. So,
yeah, okay.
Why? But anyway, so we make advanced composite products, and we do this in a lot of markets. One of the markets is unmanned systems, and I will only give one or two examples of what we actually do. And this one was one of the last one. It's for helicopter system. In the French part of the country, it's in Wallonie, and for these guys we actually made a composite carbon Dynema fuel tank, which was actually able to resist also the necessary G loads which occur when, for example, this thing would drop out of the sky or something. So these fuel tanks are full with kerosene. So that would have been a small disaster if they would fall off. And apart from that, it was not only used carbon fiber, but also Dynema fiber, which assures that you cannot penetrate these fuel tanks, so they don't lose their kerosene when flying. That's one thing we do for unmanned systems. The other market which we work in is our industrial components. Two examples. This is one, if somebody knows something about carbon fiber, this is a full carbon pitch fiber beam. It's a very stiff carbon fiber. I think it's one of the stiffest probably, the CN80, and it gives a stiffness of around 400 gigapascal at best. So it's not bad. Huh? If you compare this to steel or the strong or the normal carbon fiber. Another project we did was the rotor and stator blades for a dispersion ventilator, which is used in the agro industry. You should imagine this small picture actually as something which has a diameter of 1.5 meters, and it's turning about 400 RPM in actually a corrosive environment actually. So it had a special coating on it too. Next.
So every gram saved counts with those inertias.
Yes. Well, also, it was too expensive to make them in inox, and it cost too. And it's indeed, as you say, it's too heavy. And also the thing was actually that we had to make it We had to make it in carbon fiber because the glass fiber would have been attacked by the environment, and it has a special coating on it.
It's good to hear that there's a cost advantage as well, because very often it's not the case.
No, it's very different. As you say, we're a small company, and the problem is actually that selling advantages is much more difficult, actually, on a cost basis. So one of the last projects we did actually this year was we participated in the refit of the Coral Ocean superyacht, and they had to change all their lift raft launchers, which were made in steel. And in the first picture, you see this lift raft launcher open. We also have some on the website closed, but they're made in full carbon fiber, so they're very light. That was actually the purpose of this. I think we delivered for, if you see on the other lower, these are the lift raft launchers. We delivered something like six sets for this one. It was actually successfully done for this super yacht. Then these are some projects from some time ago, some years ago. Actually, we made the casings for this whole hail drone, which goes into the stratosphere. It was a project from Vito, and we actually made the casings in also at that time in a very stiff and high temperature epoxy system, so it could handle the loads it's experienced in space. It's temperature difference and outgassing and so on. And the other thing was actually we were in competition with a Swiss company, and we were the guys who could make for this ESA Moonlander these struts. So they corresponded actually to the drop test simulation of Thales, which was actually quite difficult. It took us long. And we did this together with Kinetic.
Ah, yes.
So actually now why we're actually could participate in this Singapore mission is actually we also are very busy with the development of composite materials. And these these composite materials are based on the using industrial residues, like from copper slag, blast furnace, granulated, recycled glass, carbon fiber, you name it. And we do make actually composite materials with these, but on a basis of an inorganic cementitious matrix, actually. It's also on the slide. So the reason why this inorganic cementitious matrix is that first of all they have the capacity of very high temperature, which is a problem for organic resins. I think polyamide only goes to 300 or 350 degrees, and it's also very expensive. So the resins we are developing or working with, they go much higher in temperature. Actually, they give the fibers the possibility to go to their limit temperature use. For example, carbon fiber starts oxidizing at 700 degrees. The polyamide will be gone before the carbon fiber starts oxidizing, but with our inorganic matrix, it's the other way around. It depends on what kind of formulation we use, but we can and we could go up to 1300 degrees. So there could be also further an alternative for existing expensive ceramic composite solutions, because there exist composite solutions for this kind of high temperatures, but they're very expensive. Geopolymer inorganic cementitious matrix could be a cheap solution for this kind of problem.
Do I understand correctly, Stefan, that you're mainly looking for partners to help in this development?
Yes.
Yeah.
Because I think the first things we actually presented, I think they also do this in the States, in Singapore and Japan. They know to process these products also very good. I'm sure from that. Huh?
Okay, thanks a lot. It's
No problem.
I didn't know all of the three companies as well as you might know each other, so it's a good introduction for me as well.
Yes.
Joining in the Singapore mission will be these four companies from France, again in the top left. A company offering a recycling process for PET. In the top right from Poland, a company which is specialized in surface treatments, but also offering technical textiles based on wood, wool, and felt. In the bottom left, a company from Italy that produces production machines and production lines for non-woven textiles. And then in the bottom right, an Italian family company that produces wooden chairs, and they also want to explore new materials and see how chairs could be reused at the end of their life. As a summary, let's say we will do 3 missions. 15 companies will take part, 5 from every region. And the goal is to set up some cooperation agreements and business agreements, and in the long term also cooperation projects. So we hope that we can create some synergies by going to these target markets together and talking to each other and finding out how these companies can help each other out. I think that's about it for the organized or orchestrated part. I don't see any questions in the chat, if I'm correct. But if there are questions at the moment for me or for any of the companies or for our guest speaker from Vito, feel free to go ahead. I'll wait a couple of moments to see if anyone opens his microphone or puts up his finger. You might have a question for Sabine. You were talking about future product being larger tanks above 2,000 liters. Which application is envisioned there?
I don't know. It's, for instance, maybe for trucks.
Yeah.
Well,
Possibly automotive, let's say.
Yeah.
Yeah. Okay. Any synergies or interesting new companies that you have spotted in these slides? Maybe Eveline, I'm not sure if you know all of the textile companies that passed by on the slides.
No, I did not know all of them. No.
And did you
So
know the clusters?
I knew some, yes. We are now mainly working together with French partners, also in research, as well as Austrian and Belgian, of course. But we do not have any partners, for example, in Italy. But we know that there is a lot of work ongoing there. So it's really interesting also to hear that. Yeah.
Yeah, I have the impression that NTT is involved in quite a lot of projects also as coordinator. So yeah, I have up to now a good experience with them.
I've noted their name.
Yeah, I can get you direct contact details.
Perfect. Thanks.
Yeah, to finish, if you are interested in contacting any of us, on the final slide you find the names, the companies, and our email addresses. I hope I get them right, but normally I've received emails from all of those, so they should be correct. I think that's it for now. I don't see or hear any other questions, so thanks for the attention. Thanks also to the presenters for preparing their slides yeah, just based on a few lines in my mail. So very, very nice and very good workshop or webinar that we set up here. Thanks a lot.
Sorry, last question actually.
Yes.
Will we receive the presentations of the others?
Yes, I will. I will make sure first of all that this slide set is made available to you, and I will also check within the project we had similar workshops in the other regions where the other companies present themselves in a more extended way than I can. So also that I will check and I will provide it to you, Stefan, to Sabine or Tony, and to Thomas.
Yes, and then a last question. When will there be a follow-up before we actually board the plane?
Yeah, good point. I think with Thomas we will do the first follow-up. I discussed it with the project coordinator yesterday. I'm not sure yet about an exact timing, but it will be somewhere in August, I guess.
Next.
But for the other missions, I'm not sure yet. They're still further away.
Just to know when to expect something. So next year in August, we will expect some news from you.
Yeah, but we'll stay in touch in between, Stefan.
Yes, no problem. Good.
Good. Yes. Good questions. Thanks.
I just want to know that.
Okay, that's it for this webinar. Thanks a lot, everyone, and
Thank you.
you'll get the information by mail.
Thank you, Jan.
Bye.
All the best.
Bye-bye.
Bye. Bye. Bye.